Hello, welcome back to Danger's Workshop. You are live and uncensored with Robert Danger Bird, CEO, mountain climber, inventor, and magician. I have here on the bench behind me the components required to build the brains for the OxiKit. I'm going to explain the various components, talk about options, and then walk you through the assembly process. So without further ado, let's build a brain. So this is what we're building. This is the completed brain from one of the OxiKit prototypes. And if you can gain access to the components we've used here, the DIN rail components will make your life much easier. You can see the power supply, the terminal strips, the relay board, the Arduino and its terminal shield, all on a DIN rail mount. That DIN rail mount will make your life much easier. Very easy to secure the components, easy to wire, plus it just looks damn sexy. Okay, so starting in the center, we have the Arduino processor. This is an Arduino Uno. The Uno is a very inexpensive, you should be able to find these for around $20. And an Arduino Uno. The Uno is a very inexpensive, you should be able to find these for around $20. And they're very simple to program, very easy to connect to, have a lot of options, plenty of input-output, and are very well suited for this project. The way you normally connect to an Arduino is with these little project cables here, and they have a little pin that just slips in just like that, right? And you could certainly connect your project that way. The problem we have with this is I've found that these get loose, and the more you handle it, the worse it gets. And then you end up with loose connections, valves not firing, valves turning on and off. So I don't recommend this. I recommend that you convert to a terminal, and this is a terminal shield here, and a shield is a Arduino term that simply means something that connects to an Arduino and gives it additional functionality. In this case, this is a terminal shield, so we plug it in and it gives us these nice outputs on the side here that are screw terminal and hold the wires very firmly so you won't have any problems with loose connections. I also like this particular shield because it is a DIN rail shield. What that means is it will snap onto a DIN rail. This is a 12-inch DIN rail. DIN is a German acronym. It stands for Dimension Industrie Normen, and which is German for same size. And it will just snap right on. So it makes it very easy to mount your components, and all of the components in this project clip to the DIN rail, which makes for a really nice clean package. It's very easy to assemble. So moving on, we have the relay board. This is also a DIN rail board, which again snaps onto the DIN rail. You don't have to use a DIN rail board. There are other options for this, and in a later section I will show you other options. But this one I really like because it is DIN rail, and it also has screw terminals right on the board, which makes for really reliable connections. And then this component is a power supply. Yeah, this is again a DIN rail power supply. It takes the 110 to 240 volts AC in, so people in other countries with 240, this will work there as well as here in America where our typical outlet is 110. You would just connect the lamp cord to the input and your output wires to power the Arduino and the relay board, and you're set to go. There are other options for this as well, which I'll cover in a later section. And then here we have just a screw terminal. And this also clips onto the DIN rail and gives you a really clean place to make your input connections. And this is simply a lamp cord. Just pull this out of an old box of cords. And I like the 2-conductor kind. It's a little easier to work with. We don't need a ground in this case, and it makes it nice and clean. And then there's I have 3 different colors of wire. I have 6 feet of red. This is a 22-conductor. Stranded wire. I've got 3 feet of yellow and 2 feet of black. And then tools, we'll need a 2mm screwdriver. We'll need some nippers, some strippers for stripping the insulation off of the wires, and then we will need a ultra fine point Sharpie. So that's everything required to build a brain. Let's move on to the next section. So in this section, we're going to talk about alternatives, and we'll start with the Arduino. So with the Arduino, you have a few different processors. There's the Arduino Uno, the Arduino Mega, and the Arduino Nano. So these are all the same processor, they just have different input output. So the Nano is the smallest, and it can power a OxiKit. We do have one running on a Nano. You've got the Uno, which is my personal choice, and then you've got the Mega. The only difference is the amount of input output and the size of the board. The other thing that you will want to use is a shield of some sort, especially if you use the Nano. And a shield is simply something that plugs into an Arduino that gives you additional functionality. And so this is a terminal shield for the Nano, so you would plug that in and that would give you your connections. Very clean, very simple. Then on the Mega, you've got the same sort of thing. This is another shield for the Mega, and as you can see, the Mega has a lot more input output. We don't need all that, but if this is all you can get your hands on, then it will certainly work. And then, of course, the one that we chose for our project was the Uno. And in this case, we are using a DIN rail mount shield to give us the terminal connections. So the other thing that you could do is you could buy a little project box. So this is an Uno project box, and the Uno goes inside this box and it gives you the screw terminal connection. So that's another option. Now for power supplies, this is a really nice solution, very clean, very elegant. You can also just use a wall wart. This is a 5-volt DC wall wart. It just takes your 110 alternating current and converts it to 5-volt DC on the output, which you can plug directly into an Uno. And the Uno can provide power to the relay board, eliminating the need to connect power directly to it. I prefer to connect power directly to each of them. I've had best results doing it that way. And on the terminals, these are primarily used to deal with the alternating current coming in from the wall, and I connect the positive and negative, or the neutral and the hot, and which is a more technically appropriate term, to these two terminals, and then I spread them out to go to the other pieces of the project, and you'll see how that works as we move to the tutorial section. You could also use a standard barrier strip or one of these flexible type barrier strips, which you can cut off to get the number of connections that you need. And then another option is the actual relay board. So I've chosen a DIN rail mount relay board here, which I really like for the cleanliness of it, the reliability of it. I like the terminal arrangement on this one, and I also like how it's super clean. It makes a really nice package when you're done. This is another option. This is your input here. This is your output. So this is going to require you to solder onto these pins to get a reliable connection. And some people are good at soldering, some people aren't, but that's another option. And then this is another type of relay board. This just gives you more. It's similar to this one, and the connection type is similar. You would have to solder these pins. You can use these little slip-on project cables, which is what the Arduino comes with, but you're going to have reliability problems with that. So that's another way to do it, but again, I don't recommend that. If you do use this type, I recommend that you solder directly to these and make your connections that way. So those are some of the options, and as you can see, there's a variety of ways to put this together. If you can get your hands on the parts that we've chosen for our project, it'll make your life quite a bit easier and make the project more reliable long term. First step will be assembling the Arduino and the shield package. Now, before we do that, there's a nuance I want to discuss with you. So on this board, you'll see the pins here are actually labeled 5, 6, 7, 8, and we can see pin 5 is right here, and that corresponds with pin 5 on the Arduino. So if we plug this in, pin 5 and pin 5 are going to line up there, right? Nice and neat. However, on the output side, pin 5 is actually way over here. So pin 5 is here on your connections, but actually on your output terminal, it's here. So you need to be aware of that. And I've labeled them on my shield just to make it easy, and suggest you do the same. I've also made this little sticky note here to give you a quick way to get there. So we're going to start at 0, 1, 2, 3, 4, pins 5, pin 6, pin 7, and 8. And those are where we're going to make our connections. Again, on mine, I've labeled them 5, 6, 7, and 8, so I don't make a mistake when I'm doing the wiring. And the same situation is true on the other side. And so I've also made a little sticky note here that I could put on there that we can count. Now on this one, it's labeled a little differently. There actually is a pin 0 here, which you can see, and a pin 1. Over here, they're labeled A5 through 0, and then they start with the power terminals. So we're just going to call this first, and then we'll count 1, 2, 3, 4, 5, 6, 7, which is ground, 7th pin, that's the universal ground symbol, and 8th is going to be the 5-volt connection. So that's what you need to know about connecting to the shield. It's actually very simple, and there's only a handful of connections to make, 6 in total. So it's very straightforward, very simple, just need to be aware of that offset nuance. So we're going to take and assemble that onto the board, and then we're going to take our DIN rail, and it just slips right in that channel, and you just snap it in place, and it will slide. Right. And then I'm going to take and snap in the relay shield, and then I'm going to take and snap in the barrier strips. Push those in. And then the power supply. And now we have a nice, neat little package. So now let's get on to the wiring. So now it's time to wire up the brain. First thing we're going to do is we're going to identify the terminals that we previously marked. Remember, we used our nifty little Sharpie, and we marked these positions here, 5, 6, 7, and 8. And on the other side, we marked the power and the ground for the Arduino. And we're going to back those terminals out as these come in the closed position. And so we just need to go in and screw those out. And I've already done it on the relay board, so that will save us a little time in the video here. Now, first thing I'm going to do is I'm going to take my red wire, and I've already stripped back the end of this, and I'm going to place that in the 5-volt position. And I'm going to tighten that down. Okay, and that's what I really like about these connections. That is not coming loose. I mean, the wire will break before that lets go. So I highly recommend converting to screw terminals for all of your connections. So I'm going to pull this down, and I'm going to snip it right there. And then I'm going to strip back this section here. And I'm going to connect it to the VCC terminal on the relay board. And then tighten that down. Check that connection. All right, I've pre-stripped this one, although I stripped it a little long. See, that's too long. That'll have wire sticking out. It'll look bad, make you look like an amateur, but it could also short, especially if you get a strand sticking out. So I'm going to trim that down to about 1/8 of an inch. And then I'm going to put that in the ground section. Marked GND on the relay board. Again, very solid connection. Pull that down here, snip that off, and then strip an 1/8 inch off. Connect that to the ground terminal we previously labeled. on the Arduino shield. Check that connection, it's good. So now I'm going to take all of these wires. I'm just going to kind of hold them and manage them, because I want to get down here and I want a nice clean flow of the wiring. All right, so I'm going to start there. And I'm first going to connect my positive terminals. All right, and I think that's longer than I want, so I'm going to shorten that some. So that's how that's going to lay out, and that looks pretty good to me. So I'm going to strip that back an 1/8 inch. And then I'm going to check this wire. Yeah, that looks good to me. So I'm going to strip that one back. Place both of those into the positive terminal. Tighten that up. And do the same thing on the negative. That's a little bit long, so I'm going to trim that some. I'm just pushing it in there, and I'm just kind of looking, because I want the wires to flow nicely, just so they look neat. I'm going to strip that back. And this one looks pretty swell to me. Strip that one back. Insert both of those into the negative on the power supply. Make sure I've got them pushed all the way in. I want to get a good solid connection there. Okay, so now we've got power and ground on our relay board and the Arduino. And the wires are flowing nicely. Next, we're going to take our yellow wire. I'm going to strip that back. And we're going to start on terminal 5. Remember, we pre-labeled these earlier using our little micro Sharpie. And I'm going to start with terminal 5, secure that one. And terminal 5 will drive relay number 1. And so that's going to come over here. And my plan is to attach these wires here. I'll put a tie wrap there. And then I'll bend back over here to catch that connection right there. That way the wires have a nice, visually pleasing flow. So they're neat and orderly. And that's going to go into terminal A, or relay A. All right, I'm liking that. I'm going to repeat that process. Strip it back about an 1/8 inch. This goes into terminal 6. And then we're going to just follow this wire around. Just a little game of follow the leader now. Just pinch those wires together. And I'm going to use my nippers to cut right there. And I strip back an 1/8 inch. Insert that into terminal B. And tie that one down. All right. Two more to go. And again, we're going to strip back an 1/8 inch, give that a little twist. That goes in terminal 7. Oh, I'm on the wrong terminal. I need to be right there. All right, there we go. Terminal 7. And once again, we're going to follow the leader. Come around. Snap that off right there. And that goes into relay C. All right. One left. So when you're stripping with this type of stripper, you can use this little dial here to stop the setting so it won't go any further. I prefer to do it by feel. That way, if I'm stripping different size wires, I don't have to constantly change this. But it's up to you, whatever you're comfortable with. If you don't use this and you go too far, of course, you'll cut through the wire and you'll strip away some of the actual conductors, which you don't want to do. If you play with these a bit, you'll kind of get a feel for it. You really just want to squeeze into the insulation and then pull it off and let the insulation tear away without actually cutting into the wires. So that's the idea anyway. All right, so this one's going into terminal 8, and then we just follow these wires around. And then once again, we're just gonna lay it across the top there. Snip it right across there. Let's see how straightforward this is. And then push that into relay D and tighten that one down. All right, so now we have our power for the Arduino, our power for the relay board, and our control signals are connected from the Arduino to the relay. So the first 3 are the valve relays. The last one, pin number 8, is the fan relay. So I'm going to come over here and just to neaten things up, I'm going to put a tie wrap here. I'm not going to completely tighten that yet. I'm just going to snug it up. All right, and I'm going to put another one over here. Okay, now I'm going to snug those up. I'm happy with that. I'll trim those off. All right, so that's all the connections required on this side. So now we're going to make the connections on the other side. So now we're dealing with the alternating current coming into the project. And so I'll be using these terminals here to connect the lamp cord to. And because these are wedged in here, it's actually a little easier to pop these off and make the connections outside and then slip them back in. So we're going to need our lamp cord. And so I've already stripped that back, and this is a non-polarized lamp cord, meaning it doesn't have a larger lug like some of them do. It really doesn't matter. It's alternating current, so there is no polarity. It actually changes polarity 60 times per second. If you had a polarized cord, then I'll show you how you would deal with that, but it's not really important. All right, so we're going to need our neutral, which we'll use black for. This is for the power supply. And then we're going to need our hot, or line. It's labeled L on the power supply here, which is the standard nomenclature for your hot wire on alternating current. All right, and so those will simply make a little loop and go right in here. So I'm going to go ahead and trim those off. And strip those back. And I'm going to strip a little further on this because these are deeper. And that'll give us more wire to bite and give us a better connection. Now, we need our power input for the relays. And we're going to use the common terminals, which are right here. And each relay will come right over here. A little too much. I'm going to cut that back. Have another one here. Give that a little better twist. Okay, so I need to back this out more. There we go. Okay, so there's that one. Okay, looking good. And relay number 3. Trim that one the same. The last one, relay number 4, which is actually for the fan. Alright, so now I'm going to strip all these back, and as I did earlier, I'm going to strip back a little more on this because these are all going into these rail terminals, which are deeper than our screw terminals. So I'm going to take all of these and line them up. So I want the tips to be even. And that is our power for the power supply. And then I'm going to turn it this way. I'm going to slip all those inside there. I want to make sure that I've got all of the wires pushed to the back. There's a little shoulder here that they're going to hit, and I'm going to tighten that up. That's going to lock those wires in very firmly. And we do the same thing for the negative. I'm going to slip that one in. That's my power supply negative. I will be adding more wires. I'll be adding the negative, or the neutral, actually more accurate term, for the relays. That's where they'll be getting their neutral from. They'll be getting their voltage, or their line voltage from the relays, but they'll be getting their neutral from here. Now I'm going to connect this non-polarized lamp cord on the other side. And again, I want to make sure it goes all the way to the back. Right? I don't want wires hanging out. And I'm going to tighten that down. And we'll put this one here in again. Make sure it goes all the way to the back. Tighten that down. So that's essentially just completing a connection. You can see it's connected here. There's a little bar that goes between the terminals, and it connects the output here. So just as a real easy way to add connections. Now I'm going to take and snap these back on the bar. And so you want to hook this side. It's easier to see what you're doing from the bottom. So we'll take and we'll hook those in right there and then snap them on the rail. And there we go. So now I'm going to take and put a tie wrap there just to neaten that up. Trim that off. And that is a completed brain. So let's plug it in. And she's alive. So this fourth one is the fan. So the fan has switched on and it stays on. These first three are the valves. So you'll see the valves cycling through. This is sieve A valve, sieve B valve, and this is the pre-charge valve. We can also see we have power here. We can also see here we have power. So we've got a few indicators that everything's copacetic. Next step is to connect the valves to the brain. So in this section, we'll be completing the control system by connecting the valves to the brain. It's very straightforward. I don't want to walk you through it, so you'll know exactly how to do it. First thing we're going to do is pull this screw out, and that will allow us to pop off this connector. This is a DIN connector. You remember what that stands for from our previous video, right? DIN is German for Deutschen Industrienormen, and it just means same size. When you open this up, there's a couple of screw terminals inside, which, as you know, I'm a big fan of screw terminals, and I've already popped these off of the other valves. And so we're going to pull all of those out, and then, and these are from two different types of valves, but they're all interchangeable, and they all have LEDs on them, which I like because you can see when the valves are firing and verify your connections. So I've got 3 sections of wire here, and these are a couple of feet each. I would actually be wiring these after mounting the valves in the system, but I wanted you to see the entire electrical process. So I'm just going to wire these up directly to the board with them loose. All right, so we're going to take and back out these screw terminals. And these are alternating current valves that I'm using here, and so polarity doesn't matter. However, for consistency, I always put the red on the right. And so I'm going to slip those wires into those little pockets there. And I want to make sure that I've got bare wire underneath that clamp before I tighten it down. So I pulled it back just a little bit. I'm just going to tighten those up. And then I'm going to take and I'm going to pull those right around this little pin in the middle here. All right, so now we can see we've got the red on the right, black on the left. I've stretched them over this little pin, and then I'm going to slip this wire into this little hole here. And that completes that side. So that will simply slip right onto the valve like that. And then the other end will be connecting to the board. So I'm going to prep the other 2 harnesses. Okay, so the valve harnesses are complete, and I've got a couple of feet of wire here, and I've stripped back 4 inches of the insulation, and I've exposed these wires, and I've already stripped the ends here. I'm going to take these black ones, and I'm going to join them together. And these are going to connect right here. I'm going to push those in. Helps to twist those together. And insert those right into the terminal there, and I'm going to tighten those down. And that is our supply voltage for the relays, or the neutral actually for the relays. Neutral for the valves to be more accurate. And then I'm going to take and connect these into the normally open connections on the relays. And And that completes the valve wiring. Now if we take the valves and connect them, at this point I'm not paying any attention to which valve is which. I'm just showing you that it actually operates. And I'm going to plug in the board. You'll see the relays firing. And this one is very noisy. So this relay actually has a problem. But that is how they wire them. And this is a completed control system from brain to valve. And the final piece of the puzzle is the fan. It's very straightforward, so we will go through that. The one that we've chosen has a molded connector, which I really like, and we'll just connect that right there. It is an alternating, put those terminals a little closer together so we're landing in the center of those spades. There we go. Okay, so now we're connected there. I'm just going to cut this end off. Once again, it's alternating current, so there is no polarity per se. One I'm going to strip a little longer because it is going over here. It's going to slip into this neutral connector, the blue one, with this other bundle of wires. See how some of my wires got pushed back? Be careful about that. And so I pulled out, retwisted, and took another shot and got a clean stab. And then the other side goes to the output, or the common, not the common, the normally closed connector, or normally open, which is the first one. First open, last one's normally closed, common is the center. So the way these work is this is our power in, this is our power out. Over here we're picking up our neutral. It's the same for the fans and the valves. So now if we turn this on, after the test sequence, you'll see the fan start spinning. There's a very short test sequence that the board goes through, which is part of the program. And that is a completed control system with all of your valves and your fan, everything controlled by the Arduino. The only thing remaining is to learn how to program the Arduino itself. Hello and welcome back to Dangerous Workshop. In this module, we will be covering the programming of the Arduino microprocessor. Now, for some of you, that may sound intimidating, but I assure you it's very simple. The software is very easy to use, and I'm going to walk you through every step of it. So first, you will need an Arduino processor. I have the Arduino Uno in my hand. You will also need a type A to B cable for the Arduino Uno. If you're using a Mega, it will use the same cable. If you're using a Nano, it requires a micro USB cable. On my desktop, I have three items. The one on the left is the OxiKit code. You will find that on oxikit.com. Special note, you will need to maintain the folder structure. The Arduino software expects that. This is the Arduino software installable, and this is a link to the website where you can get the installable. Arduino.cc is where you'll want to go. I'm going to click on these three bars here, click on Software, Downloads, and then I'm going to scroll down and select the operating system that I need for my OS. You'll choose the one that's appropriate for whatever you're working on. They do give you the opportunity to make a donation here, and I recommend that you do. Arduino is doing some good work in the maker community, and they deserve and need your support. However, if you're a tightwad, you can click just download, and then it will begin the download. I've already got the software downloaded on my desktop, so I will simply start the installation. Run. I agree to the terms and conditions, the largest lie in the universe, one that we all tell we have read and accept the terms and conditions. Have you ever actually read terms and conditions?
hence its classification as the biggest lie in the universe. All right, so this will take a little time. So how about I share some computer humor with you while we wait? So, how many programmers does it take to change a light bulb? None. It's a hardware problem. An SQL statement walks into a bar and sees two tables, and he says, "May I join you?" How about this one? As Maher is often fond of saying, "I'm not interrupting you, I'm putting our conversation into full duplex mode." Okay, I'll dig deeper. A man walks into a library and says to the librarian, "Do you have a book for men with small penises?" The librarian looks at her computer and says, "I don't know if it's in yet." The man says, "Yeah, that's the one." All right, enough of that abuse. Oh, and look, we're almost finished. We may have time for one more joke. What did Stephen Hawking say when his computer crashed? Absolutely nothing. And look, we are completed. So now that the software is installed, we simply open the OxiKit folder and double click on the INO file. That will open the Arduino software. And then we go to Tools, and we will double check that we have an Arduino Uno selected. If you have a Nano or a Mega, you would select the appropriate board. We also want to select the port, and I can see it's on port 15 there. And very important to make sure you've got the port correct. Many of your problems are going to be because you haven't gone in and told it what port. It's going to default to COM2, but it will pop up with Arduino Uno in the spot where that board has landed. So make sure you check this. And then we simply hit program. And that's all there is to it. The board is done. The program is now running on the board. And we can now take that and install it onto our OxiKit Brain. And we are done with the control system. Like magic.